Welcome back to the official channel of Amit Ranjan. Today, we have an incredibly exciting topic to discuss: genetically modified, GM, mosquitoes and how they are poised to revolutionize the fight against mosquito-borne diseases like dengue, malaria, and chikungunya. But before we dive into this fascinating subject, if you're new here, don't forget to subscribe and hit that notification bell so you never miss out on our latest updates. Alright, let's get started. Mosquitoes, those tiny but formidable creatures, are responsible for transmitting some of the deadliest diseases known to mankind. But what if I told you that science has developed a groundbreaking solution that could change the course of disease control as we know it? That solution is genetically modified mosquitoes. As the yearly public health crisis intensifies, measures include removing breeding sites and using insecticides. But scientists are working on a new solution that turns the enemy into a potential savior. To truly appreciate the significance of genetically modified mosquitoes, we must first understand the magnitude of the problem they aim to solve. Each year, millions of people worldwide suffer from diseases like dengue, malaria, and chikungunya, all transmitted through the bite of infected mosquitoes. These diseases result in hundreds of thousands of deaths and countless suffering. Traditional methods of mosquito control, such as insecticides and bed nets, have had limited success. We need a game-changing solution, and genetically modified mosquitoes might be it. So, how do genetically modified mosquitoes work? Well, scientists have engineered these mosquitoes to carry a specific genetic modification that hinders their ability to transmit diseases. To have a better understanding of this new invention, let us see one of the research works going in one of the places of Central America, Honduras. In Honduras, millions of special mosquitoes are being released. These mosquitoes were bred by scientists to carry bacteria called Wolbachia that interrupt transmission of the disease, as per the information shared by the Associated Press News of America. When these mosquitoes reproduce, they pass the bacteria to their offspring, reducing future outbreaks. This is being tested in about a dozen countries. Scott O'Neill, founder of the World Mosquito Program, is one of the pioneers of this solution. He was originally looking at the bacteria as a way to eradicate mosquitoes, but his team realized that mosquitoes carrying Wolbachia didn't spread dengue, Zika and chikungunya. This meant that they could be used to replace the infective local mosquito population. A 2019 trial in Indonesia showed a 76% drop in reported dengue cases after Wolbachia-infected mosquitoes were released. Let us see one more experiment in different country. British biotech firm Oxitec has a similar solution that has trialed in Florida, where genetically modified Aedes aegypti male mosquitoes that most commonly spread dengue were released. The goal was to have them mate with the female Aedes mosquito to control the population. Oxitec has done similar trials in Maharashtra's Davalwadi village in 2017, though larger-scale open-field trials never took place. The key modification involves altering the mosquito's genes so that they can no longer carry or transmit the disease-causing pathogens. In the case of dengue, malaria, or chikungunya, these genetically modified mosquitoes can't pass on the disease when they bite humans. Now, you might be wondering, how are these GM mosquitoes released into the wild, and what impact do they have on disease control? Typically, these mosquitoes are released in affected areas, where they mate with wild mosquitoes. Since their offspring inherit the genetic modification, over time, the disease-carrying mosquito population decreases. Studies have shown that GM mosquitoes can lead to a significant reduction in disease transmission, ultimately saving lives and reducing the economic burden on affected communities. Of course, with any new technology, there are concerns. Some worry about the ecological impact or unintended consequences of releasing genetically modified organisms into the environment. To address these concerns, scientists conduct rigorous safety assessments and carefully monitor the effects of GM mosquito releases on local ecosystems. The future looks promising for genetically modified mosquitoes. Researchers are continually working to improve the technology, and we may soon see these mosquitoes used in more regions to combat a wider range of mosquito-borne diseases. Now, before going to conclusion part, let us just have a look at whether this whole experiment is economical or not. This strategy is not cheap, which raises questions about its scalability. The Honduras trial will cost $900,000. Also, it is also not yet clear whether this will work on every strain of the virus, leading some to argue that more lab experiments are needed before they're released into the wild. Conclusion. In conclusion, genetically modified mosquitoes represent an exciting frontier in the fight against mosquito-borne diseases like dengue, malaria, and chikungunya. With careful planning, monitoring, and continued research, we may finally have a powerful tool to reduce the devastating impact of these diseases on our communities. Thank you for joining us today on the official channel of Amit Ranjan. If you found this video informative, please give it thumbs up, share it with your friends, and leave your thoughts in the comments section below. And remember to subscribe for more enlightening content. Until next time, stay safe and stay informed.